Good morning, children. Today's topic is Maxwell's prediction of EM waves. Yesterday, I told you to remember the third and fourth Faraday's Maxwell's equation. A line, a time varying magnetic field, is a source of changing electric field. A time varying electric field is a source of changing magnetic field. That is, change in either field produces the other field. He further showed that these variations in electric and magnetic fields occur in mutually perpendicular directions and have waves like properties. Once again, change in either field, either electric field or magnetic field, produces the other field. If any one field changes with respect to time, it produces the other field. Maxwell he showed that these variations in electric and magnetic fields occur in mutually perpendicular directions and have waves like properties. And this led to the idea that a wave of electric and magnetic fields, both varying with the space and time, should exist, and he named this as electromagnetic waves. An electromagnetic wave is a wave radiated by accelerated charge. You know, when charge accelerates, when charges are in motion, it produces electric field. An electric field, according to Oersted, it produces the magnetic field. So accelerated charge produces a wave, and that can propagate through space as coupled electric and magnetic fields. They oscillate perpendicular to each other and also perpendicular to the direction of propagation of wave. You can see the diagram below that. You can see that is a diagram. Usually when we draw the wave, what we do? We draw only one wave. Only we draw electric field wave. You can see here two waves here. One is electric field wave along the y-axis and other one is magnetic field along the z-axis. Till 10th standard what we do is we draw only two-dimensional diagram, that is only electric field to represent light wave. But actually it is a three-dimensional picture. The light wave is electromagnetic in nature. It has both electric and magnetic components. Electric field along the y-axis, magnetic field along the z-axis, and wave is propagating through x-axis. So x-axis is the direction of propagation of the light wave or electromagnetic wave, and that is perpendicular to both electric and magnetic components. In 11th standard you have learned about the plane progressive wave. The plane progressive wave equation is y is equal to a sine omega t minus kx, or you can use y is equal to a sine omega t. Instead omega t can write kx minus omega t, both are allowed to write. Okay, but here we are using the same formula to represent electric and magnetic fields along the y and x axis respectively. So Ey, electric field component Ey is equal to E naught sine omega t minus kx, and here x represents the direction of propagation of wave, and suffix Ey represents electric field is along the y-axis. E naught is the maximum component of electric field, that is called the electric field amplitude. Then magnetic field along z axis is taken as Bz is equal to B naught sine omega t minus kx. Here in both equations, the sign component is same. It represents the wave is propagating along the x-axis. Ey and Bz represent the electric field and magnetic field at any time along the y and z axis. E naught and B naught are the electric and magnetic fields amplitudes, the peak values. And Maxwell showed that the ratio of these amplitudes E naught and B naught is equal to c, that is speed of light in vacuum. Thank you.